discuss the equivalence relation. In previous class, we already discussed about the relations, different types of relation. You learned that mainly three types of spatial relations, that will be reflexive, symmetric, and transitive. If any relation follow these three types of relation, reflexive, symmetric and transitive, that will be equivalence relation. You have given one of the problem, one of the set A having 1 to 6. Rule of the relation y is divisible by x. Y is divisible by x. That means second element of ordered pair is divisible by first element of the ordered pair. First you prepare the set of ordered pair that follows the rule of relations. Rule of the relations, you take the elements from this set. This is binary relation. That means R is subset of A cross A. That means both the elements of the ordered pair be part of the set A. Now you prepare the set of ordered pair according to rule of the relation. 1 is divisible by 1, 2 is divisible by 2, so on up to 6. Second, 1 divide all the elements 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2 is divide the 4, 2 is divide the 6, 3 is divide the 6. So you prepare a set of ordered pair that follows the rule of relations. Now you want to find that relation is equivalence or not. First you go on reflexive, in which both the elements of ordered pair be identical. That means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. These are identical elements of ordered pair. So these shows the reflexive relation. Second is symmetric. In the symmetric relation, that will be if first element and second element shows the relation, that inverse is also show the relation. Suppose that 1 divide the 2. If 2 is divide the 1, that is symmetric. But 2 is not divide the 1, that is not symmetric. So inverse ordered element of the ordered pair that follows the inverse rule, then it will be symmetric. So it is not the symmetric, because if you take any ordered pair, first divide the second, but second does not divide the first, so it is not symmetric. Now you go on transitive. Suppose the first divide the second. 2 is divided by 1. Then 2 is divide the 4. 1 is divide the second. Second is divide the 4. Now if 1 is divide the 4, that will be transitive. So you see here, 1 is divide the 4. So these 3 ordered pair shows the transitive relation. 1 divide the 2, 2 divide the 4, and 1 divide the 4. These 3 ordered pair shows the transitive. So in this relation you find that it will be reflexive and transitive but not symmetric. So this relation is not equivalence relation. Now, one of the question, rule of the relation is A is less than equal to B square. That is rule of relation. You have to prove this relation is equivalence or not. In this type of problem, there are 2 types of questions be asked in previous board examination. Once A is, this is equivalence relation, on other time it is not the equivalence relation. In this case, you have taken some examples to show that is equivalence relation, and if you have taken some other examples, it will not the equivalence relation. Suppose that you have to show it is equivalence relation. Equivalence relation. For equivalence relation, it is necessary to prove reflexive, symmetric and transitive. Now, reflexive. Both elements are identical and follows the rule of relations. 2, 2 belongs to R. 2, 2 belongs to R. In case of reflexive, AA belongs to R. That means A is less than equal to A square, may be equal or not, but it will be less. If you have taken the elements 2, 2 means identical element A. 2 is less than 2 square. That means it follows the rule of reflex. In second case, symmetric. In symmetric case, if AB belongs to R, implies inverse of this ordered pair BA also belongs to R. That means if you have taken 2 elements in your ordered pair 3 and 4, first is must be follows the rule of relation, but if second ordered pair be also follow, that will be symmetric, means inverse follows the rule of relation, that is symmetric. If you have taken 3, 4, 3 is less than 4 square, 3 is less than 4 square, 4 is also, if you go on the inverse of this ordered pair, 4 is also less than 3 square. It will be symmetric. In last case, in transitive, if AB belongs to R, BC belongs to R, then AC is also belongs to R. First, second follows the rule of relation. Second, third is also follow the rule of relation. First and third be followed. You have taken 2, 3, 4. Your elements is 2, 3, 4. 2 is less than 3 square. 3 is less than 4 square. And 2 is less than 4 square. Then it will be transitive. So if you have taken these examples, these numbers, it will be equivalence relation because it will be reflexive, symmetric and transitive. On other hand, if you have proved it is not the equivalence relation, you take the identical elements 1, 2, 1, 2 according to rule of reflexive. 1, 2 is not less than 1 by 4. It is not a reflex. In second case, 2 is less than 5 square. First case we must be followed. Inverse of it does not follow. So it is not symmetric, not reflexive. In third case, you have taken 3, minus 2, minus 1. 3 is less than. First two case must be follows the rule of relation. 3 is less than minus 2 square. Minus 2 is less than minus 1 square. But 3 is not less than minus 1 square. So in these three cases, it is not reflexive, not symmetric and not transitive. So it is not equivalence relation. Equivalence relation. Now you go in equivalence class and some other problems. It is binary relation. You have taken one of the set 1 to 9. Your rule is AB and CD are arbitrary element of the relation. These ordered pair comes under the relation. Rule is ABRCD A plus B equal to B plus. This is your rule of the relation. Now you have to prove this is equivalence relation or not. First you go on the reflexive. In the reflexive you see here A plus B equal to B plus A, that is according to rule of commutative. And you see here AB are AB. That means both the ordered pair be identical. A, according to rule, A plus B equal to B plus A. It is reflexive. Now you see here symmetric. If AB or CD, you can write A plus D equal to B plus C. You change the C plus B, B plus C, you can write the C plus B equal to, instead of A plus B, D plus A. Now, you arrange according to rule of the relation CD or AB. That means AB or CD is same, follows the rule CD or AB, that is symmetric. Now you go on transitive. AB, these ordered pair belongs to A cross A. These are the part of the ordered pair of the relation. In first case, AB or CD, you can write according to rule A plus B equal to B plus C. CD or EF, EF is also part of the binary relation. CD or EF, C plus F equal to D plus E. You add the first and second, CC cancelled and D cancel. A plus F equal to B plus E. You can write according to rule A, B, R, E, F. First related to second, second related to third, and first related to third follows the rule of relation that will be transitive. Now, you go on equivalence class. According to question 2-5 is the equivalence class set of order pair XY. Suppose XY belongs to A cross A. That means according to rule XY are 2-5 both set of order pair part of the relation. You can write it XY. You can write it x plus 5 equal xy belongs to R. X plus 5 equal to y plus x plus 5 y plus 2. Now xy belongs to R, y equal to x plus 3. Instead of y, you can write the x plus 3 that is belongs to R or belongs to A cross A. Now you arrange the set of elements that have given 1, 4, 2, 5, 3, 6, 4, 7, 5, 8, 6, 9. Now, these order pair by comes under the equivalence class because 2, 5 is one of the order pair. You can solve the problem to find the equivalence relations and equivalence.